Good evening. The name of our project is Automated Lighting System, and the team members are Sona Shubhambats, Harsh Vaswani, and myself, Devansh Mehra. That's right. So this is the basic presentation overview. We'll move on with each of the topics in the upcoming presentation. Next slide. Uh, To start with the introduction of our project, we have created an automated lighting system that incorporates communication between various input and outputs with the help of various computing devices. And we have developed a model that can be employed to maximize the power savings from lighting systems in residential areas. And along with the automated lighting system, we have also developed an app that can be used to control lights from anywhere in the world. Next slide. As the graph depicts, following are the recent trends. We identified that the usage of electricity is crossing the rate at which the electricity is produced in our country, and also we identified that most of this energy is utilized in residential areas in the form of lights. So the main objective of our project was to develop a system that can significantly reduce the usage of electricity by lights, and also design a light controlling system that provides the ease of access. Next slide. Uh, coming to Coming to the literature review, these are some of the papers that we used as an inspiration for developing our model. To explain it in brief, we observed some of the key points like importance of automation in saving energy and also money, and also using wireless technology, how to use the wireless technology to connect with different automated systems. We observed the maximum extent up to which these papers were able to save energy, and through our project, we have used certain optimizations that helped us to save more energy than the current prevailing techniques. Next slide. So the methodology adopted for our model includes an ESP32 microcontroller. That is the main working backbone of our model and also allows us to integrate all the other components and make them function. We have several ultrasonic sensors that to determine the presence and exact location of any entity inside a given room, and accordingly automatically control the lights. Also, a Wi-Fi module is used to connect to the ESP32 with an Android application that acts as a light controller, and allows the person to switch on or off the lights in the hands-free mode. Next slide. This is the basic block diagram depicting the flow of our project, including all the components and their integration with ESP32. The functioning of all the components, as I already explained in the previous slide, and all these components will be connected to a power supply, which through ESP32 microcontroller. Now, I would like Harsh to continue further with our presentation.
So these are the hardware and software requirements for our project. Firstly, with the hardware components, we are using ESP32 as our microcontroller. The ESP32 comes with an inbuilt Wi-Fi module, which we will be using to connect our system to an real-time database to control it with Android device and also with the ESP32. Next, we are using ultrasonic sensors to detect the presence of a human being. We are using breadboard to connect all our devices on to it. We are using LED lights to depict the lighting system of a house, and we are using jumper wires to connect all the devices. The software components include the Arduino IDE, which we are using to put in the ESP32. We are using Android Studio for developing our Android application, which can control the lighting system from anywhere. And we are using Google Firebase for our real-time database, which will be consisting of all the data regarding the lighting system, and we can control the lighting systems using the database and the Android application. So next slide. So this is the model of our hardware component. We are using a microcontroller to connect with the real-time database, which contains the information regarding the lighting system of the house and the rooms. And we are using ultrasonic sensors to change the lighting system based on the presence of a human. So next slide. This is our Android application through which we can also control the lighting system. We have also added an function of an override button so that the ultrasonic sensors will not be working in the override mode. Only the Android application would be able to control the lighting system. So this can be toggled on and off. So using this Android application, the lightings can be maintained from anywhere using the internet connection. So next, Sona will show the demonstration of the project.
Thank you, Harsh. So I would like to start with the demonstration of the project. So this is a simple depiction of a room, and a room which has 3 LEDs. So now I'll just start the demonstration. So now we could see that when I keep my hand over the left ultrasonic sensor, so the left ultrasonic sensor is used to depict the presence of an entity in the room. So if I keep my hand over the ultrasonic sensor, and the ultrasonic sensor detects a distance which is smaller than the height of the room, and this height of the room is actually a constant that is defined in the Arduino code that is put into the ESP module. So this height of the room, let's assume it's 200 centimeters. And if I keep my hand over the left ultrasonic sensor, it detects that the distance is smaller than 200 centimeters. So it means that there is a presence of an entity in the room. And what that means for our project is that if it detects a distance less than that constant, then the LED in the middle turns on. Now we can see that I'm also using the right ultrasonic sensor for some functionality. I'll be showing it now. As we can see in the video, as we can see in the demonstration, that the right ultrasonic sensor is actually used to depict the position of a person in the room. So what we had planned in a real life model is that we'll keep this ultrasonic sensor in one of the walls, and we have defined a certain constant called the width of the room, which is actually width of the room divided by 2. And right now we have defined it as 100 centimeters. So what it is used to demonstrate is that there is this the room is divided into 2 parts: an area which is less than an area which is at a distance less than 100 centimeters to the right ultrasonic sensor, that is one mid of the room, and the other half of the room is the area which is greater than the distance 100 centimeters. So when I keep my hand over the right ultrasonic sensor, it detects that the distance is somewhat less than 100 centimeters. So it depicts that the person is nearer to that ultrasonic sensor, which means that it's on the other side of the room. So the bulb on the left, you can see the bulb on the left turns on. And if I keep my hand away from the ultrasonic sensor, you can see that the bulb on the right turns on. So it actually depicts the position of an entity. Now, moving on. Now we'll be using the Android application to control the bulbs. If I just, you can see that when I click on override, it means that the ultrasonic sensor will no longer be controlling these bulbs. You can see that the bulb is not controlled by the ultrasonic sensor now. Now, if we click, now I'm using the Android application to control the bulbs, and the interface is quite simple. Like if I long click on any of the bulbs, a change will be seen in the list item, and also we can see that the bulb on the breadboard also turns on. So you can see the bulb on now turns on, now it turns off. Same for the bulb 2. Now, moving on with the application, like Devansh and Harsh rightly specified, that this model helps us to control the status of the bulb from anywhere in the world. So now my friend Harsh will be controlling the bulb from the Android application that we did. Now you can, at the end of the video, you'll be able to see. Like you can see, I'm not controlling the bulb, but Harsh is using the Android application now to control the bulb, and and he's in Bhopal right now, and I'm in Delhi. So because of the Wi-Fi module, we are able to communicate from anywhere in the globe. So now you can see bulb 2 is on, and if he turns it off, then it will turn off. Now bulb 1 is also on, and he's controlling it from, and we are able to control it from anywhere in the world. So that's it for the demonstration part, and that's all for the whole implementation. Now for the results, like we just showed that we are able to implement the whole hardware component of the project, including we used ESP32 as a microprocessor, and all of these materials have been discussed by Devansh only. Now we connected this module with a real-time database on Firebase, and also if we are not controlling the bulb from the anode application, we are using the ultrasonic sensors to control the bulbs. Now, as the conclusion, as Devansh said, that through the project we are able to we are trying to save power, and we believe that through this simple application we'll be able to save power consumption by 35 to 40%. And so that's it for the conclusion. And through the simple project, we try to implement that how through small steps we could be able to save a lot of energy. So these are the references that we used, and that's it. Thank you so much.
Thank you.
Thank you.